Okay guys, welcome to today's class on function. So we said that this function are special kind of relation, okay? And then in this relation we have already talked about this relation in our previous class. Now we have a function if for a set, let's consider a set A to set B, every element of set A is based only on one image, okay? In that set A, then we say such is a what? A function. So if we can have a set A and we have set B and we map each element from set A and it's based on each element in set B, then we refer such as a what? As a function. Okay, so you can also see this function as an input, okay, which have kind of system of mechanism that converts to particular output. Okay, so that is what a function is. Now we normally denote this function as we are given from set A to set B as this. So this is a set of function mapped from A to what? To B. So if you watch, we are using the word mapping. Okay, so when you check out that video on relation, you understand better about this mapping. Alright, now we have different types of functions, so we are going to look at these different types of function: the real value function, the constant function, the identity function, the linear or the affine function, the polynomial function, the rational function, we have the root function, the modulus function, the greatest value integer function, the signum function, and the Heaviside function. Okay, so let's start with the first one, the real value function. Now, for the real value function, we talk about the real numbers. So we normally denote this to represent what? Real numbers. Okay. Alright. So what are real numbers? Real numbers are, you can see them as set of values that falls under the what? The number line. Okay. Such values we refer them as what? As the real numbers. Okay, so why this real value function is a type of function that produces or gives us an output that is a set of what? Of real numbers. Okay, so we refer such functions as what? The real value what? Function. Are we together? Okay. Now, this real value function, the other types, okay, they are all functioning under this real value what? Function. Okay. Now let's go to the next one, which is the constant function. Now for the constant function, okay, we look at a function, let's say f of x to be equal to k. So this constant function is from the word constant. The output is not what? Changing. Okay, the output is constant. So for every input you put for x, you always have a particular word constant. Okay, let's say that this k is equal to where k is 3. Okay, so if I put f of 2, it will give me what? 3 for this function. If I put f of 3, it will also give me what? 3. If I put f of 4, it will also give me what? 4. That is 3. Okay. Then if I put f of 5, it will also give me what? 3. Okay. So this, we refer them as the what? As the constant what? Function. You can see that from a graph, okay, where we have the x-axis and we have the what? The y-axis. Alright. Now, if we consider different points of x, say 1, 2, 3, 4, 5, and 6, okay, is a particular value of y, or you can call it the f of x, okay, such that this value is unchanging for every value you put for x. So if you put 1, you still get, let's call it k, okay, if you put 2, you still meet what? K. So for every value of x, you get what? That constant k. So that is what we mean about the constant word function. Okay, so the other type of function there is the identity function. So for the identity function, we have that we normally denote this identity function with this ID, okay, to show what identity function. So let's say we are looking at an identity function that depends on what? The variable x. Okay. Now it will give us that same variable that we put in. So what it means is that if I want to find the identity function of 2, I will get what? 2. If I want to find the identity function of 3, I will get what? 3. If I find the identity function of 4, I'm going to get what? 4. Okay, so you see, for every value of x you put in, you get that value as your what? As your output. So in this particular one, it's quite different from the constant function. Okay, because if you watch in the constant function, the input is changing. We can vary the input. Okay, but for the output is what? It's constant. Okay, but for the identity function, we have different inputs that will give us the same corresponding output. Okay, that means that the output is just the same as the what? As the input. So we refer such kind of function as the what? Identity function. Then the next list is the linear or the affine function. So from the word linear, when we talk about linear equations also, we are looking at one in which the variable has a power of what? Highest power is 1. Okay, so let's say we have the linear or the affine function. So for the linear function, let's say we have f of x to be equal to 2x plus 5. Okay, now if you watch very well, the highest power of x here is what? Is 1. So that makes it to be a linear what? Function. So we refer such kind of function as the linear function. Now when we talk about the affine, it's just a case whereby we don't include this constant, so that the affine function can now be 2 what? X. So if we have such function like this, we refer such as the affine function. So for the affine function, we do not have the constant there. Okay, that is just the difference between them. Alright, now the next function we talk about is the what? The polynomial function. Okay, now for the polynomial function, we have powers that are from 2, 3, or 4 and above. Okay, alright, but we can still look at the linear function as part of the polynomial function, because when we talk about the linear function, we talk about quadratic function with highest power of 2. Okay, then we progress to more variables with higher degree of their functions. Okay, so in that case, we refer those particular system as what? As the polynomial function. So someone can also include this under this. Okay, so why we try to differentiate this is because of this linear and the affine, so that we can take them as a special case or study. Now for the polynomial function, we have f of x to be equal to axn, okay, plus bx n minus 1, and it continues that with cx n minus 2. Okay, so such kind of functions like f of x will be equal to 2x squared plus 5x plus 4 gives us a polynomial function f of x equal to 5x raised to the power 3, 3x raised to the power 2 minus 3x plus 5. Okay, it's also another kind of polynomial function. Alright, Now the next we look at is the rational function. Okay, that is the rational function. Okay, now for the rational function, we are considering two polynomials that are dividing what each other. Okay, it gives us a rational function. So let's say we have a polynomial p of x divide q of what x is a rational function, provided that q of x is not equal to what 0. So if q of x is not equal to 0, then we have this rational function. Okay, then the next is the root function. Okay, let's talk about the root function. Now we consider this to explain this root function. This is called the nth root of a. Okay, the nth root of a. Let's say that this is nth root of a is equal to b. Okay, now from our indices we know this is the same as a raised to power 1 over n is equal to b, right? So which implies that our a is equal to b raised to power n. So for every value of a with its roots, okay, equal to a particular value, then we can say that such value of a is equal to b raised to power n. So we look at different kind of root function. You can have square root, cube root, and so on. Okay, now if most times something like this, the square root of -1, okay, if you press this in your calculator, you get more complicated values. Okay, this results to a complex number. Is an example of a complex. You can get the complex number, which we normally denote as, in some cases, I, and some cases can use j or whatever variable on alphabet is given. Okay, but basically we use I for these complex numbers. Alright, so we also discuss, we have a class where we discuss, we have already made a video for this complex number. So you can check the link below to see these complex numbers, okay, and know them very well. Alright, now that's for the root function. Then the other function we have is the modulus function. Okay, let's look at the modulus function. Now we normally denote this modulus function as this, the mod of x, okay, or sometimes we can use this to show the modulus function. Alright, so what the modulus function is telling us is that for every set of value of x that we put in, whether a negative integer or a positive integer, okay, as the input, that the result, the output is that integer, but in the positive form. So it gives us the positive integer that we have as that integer put in. So let's consider that we have the modulus of -2. Okay, the modulus of -2 will be given as what? 2. Alright, now we have the modulus of 2. The modulus of 2 will also be what? 2. We look at the modulus of -27, it can be given as what? 27. Alright, so remember, if we don't use this symbol for modulus, we can use this. So you can still see the modulus of 27 will give us what? Positive what? 27. The modulus of 0 will give us what? 0. So if you watch, for every value you put in, we have that same value, but in the positive form. So this also is a positive number. We also get the positive. Here we have a negative number. It gives us the what? The positive. So that is all about the modulus. So we can use this to show the different form of this. Let's say we have the x, positive x, we have 0, and we have positive x. Okay, so even if our x is here is greater than 0, we are going to have the positive x. if our x is equal to 0, we have what? 0 as the value. Then if our x is also less than 0, we still have the positive what? S. So it means that for all the outputs, we get what? Positive what? Values. Okay. Alright, so the next one we look at is the greatest integer function. Okay, for the greatest integer function, we normally denote this with a kind of square bracket. Okay, let's say this is the greatest value integer of x. So this is how you see it with a closed bracket. It's different, not this, it's different from this. This is wrong. Okay, so it must be in a square form this way. So let's say we are looking for the greatest value integer of x. To better understand this kind of function, it's good we look into the number system. Okay, now in the number system, we have the 0 as the neutral point there. We have this point as we go to infinity, and this point as we go to negative infinity. So we can have set of values like 1, 2, 3, and negative 1, negative 2, and negative what? 3, okay, and so on. Alright, so these are sets of real numbers, okay. Now we already have a tutorial video for number system where you talk about the natural numbers, the real numbers, the integers, and so on. Okay, so you can check that video on the link that is placed on the notification box there. Alright, so now for the number system, we look at the number system to explain this greatest integer function. Now, if we have a greatest, the decimal form of this is 2.5, the greatest value integer of 2.5. Okay, so what we do is this: we look for a point where we get that 2.5 and move a step backward or a step to the left, okay, and meet the closest integer there. Okay, so that gives us the greatest value of integer. So if at this point we have somewhere here, we have 2.5, okay, so if we move to the closest integer there, which is what? 2. So that means our answer is what? Is 2. Okay, now if we are looking for minus 2.5, okay, what will be our answer? Will it be minus 3? Alright, let's check it. Now, if we look at our number line, we are going to see minus 2.5 here, right? So if we move a step backwards or to the right, to the left rather, we are going to have this point here, minus what? 3. So our answer will be what? Minus 3. Okay, so you can get for so many values you want to get using this technique. You want to get 0.5, the greatest value integer of 0.5. So 0.5 will be somewhere here, right? Okay, so if that is the case, then we move a step backward. We are going to get what? 0. So our result will be what? Will be 0 as the output. Okay, now we are looking for minus 0.5. Minus 0.5 will be somewhere here, right? Okay, so if we move a step backward to the closest integer, what we get is what? Minus what? 1. Alright, so if you watch, you can use a simple technique to just get your answer without using the number line. So what you do is you look at it, it's a positive value for this one, okay? Since it's a positive value, the integer there becomes our what? Our answer, not the decimal. We don't consider the decimal number, okay? So we take the integer for the positive. Then if you watch this one, we have the negative of 2.5, okay? Now because it is a negative, we include our negative sign, right? But this time, this integer will move a step forward, okay? So that we have minus what? 3, no longer 2. The same thing happens here. When it's negative 0.5, we tend to move from 0 to 1, right? So we have minus what? 1. Here also is 0.5 and it's a positive number, we just take the what? The 0 and we get what? 0. Now how about the greatest value integer of 2? The greatest value integer of 2. If we are to get the greatest value integer of 2, you see there's no decimal point like we have in these other ones here. Okay, so it will just give us what? 2. If we are asked to get the greatest value integer of 20, okay, you are going to get what? Your result as what? 20. So that is for the greatest value integer function. Now the next on the list is the signum function. So the signum function, we normally denote the signum function with this, okay? So we use xgm to show the signum function. Now you are asked to find the signum function of x, okay? So this is signum of what? Of x. Now this signum function is a function that takes values only 1, 0, and minus 1. So these three sets of values are the only values you can get for the what? For the signum function. Now if you are asked to find the signum of minus 2, okay, now because in the signum function what it can only produce is 1, 0, and what? Minus what? 1. So for every value that is less than 0, you are going to have what? Minus what? 1. Like this is less than 0, so we have what? Minus 1. Then when we consider signum function of 2, now we also have that this is the three set of value that the signum function can take. So if we tend to look at any value that is greater than 0, we only be what? Giving us an output of 1, okay? So that this, our answer becomes what? 1. So you're looking for signum of 0, so any value that falls under 0 gives us what? This 0. How about the signum of 0.5? Okay, now if you watch closely, we say when the value is more than 0, this is more than 0, this is 0.5, is greater than 0. Okay, so the only value that it can take will be what? 1. So in such a way that our answer is what? Is 1. Okay, so that is for the signum function. So you can see this signum function, okay, you can see this signum function as functions that take only 1, 0, and minus what? 1. Okay? Take 1, 0, and minus 1. So even if we have our x function to be greater than 0, then it will give us an output of what? 1. Then if we have x to be equal to 0, it will give us an output of what? 0. Then if we have x to be less than 0, it will give us an output of what? Minus what? 1. Okay, so that is for the signum function. Now the next on the list here is the Heaviside function. Okay, that's the last we are going to take for today, the Heaviside function. Now for the Heaviside function, we normally denote it with capital what? H. So you can talk about the Heaviside function of what? X. So these kind of functions are functions that take values 1 and what? And 0 only. Okay, so these are the only two sets of values the Heaviside function can what? Produce. It's quite different from the signum function. The signum function takes values like 1, 0, and minus 1. But the Heaviside function takes just two values. 1, positive 1, and what? And 0. Right? So if we are asked to find the Heaviside of minus 2, of course the value there will be what? Will be 0, because these are the only two values it takes. Okay, and once the value is less or equal to 0, then we have that the only function, the output it can take is what? Is 0. Now, if we have a Heaviside of 2, Heaviside of 2 will be what? Will be 1. Once the value is greater than 2, and greater than 0 rather, then we have that the output will be what? Will be 1. Alright, so that is for the Heaviside function. So if it is Heaviside of 0, of course, our answer will be what? Will be 0. So these Heaviside functions are functions that takes 1 and what? And 0. So it will be 1 if x is greater than 0, or it will be 0 if x is less or equal to what? To 0. So it will give us this what? Outputs for the corresponding what? Value of x. So this is where we are going to end the class for today. So under function, in our next class we are going to discuss about the inverse of a function and also the composition of a function. So we see how we solve problems that concerns the inverse function and the composite function. So we are going to end the class here for